Hello friends, welcome back. In this tutorial we will study about insertion sort. Insertion sort is a sorting algorithm, right? Suppose an array A of n elements is given to us and we have to sort array A by using insertion sort algorithm, right? So we will start from second element of array A, right? And to each element up to the last element of array A, we will insert it right place in between the sorted elements which are at the left of it, right? Now it will be more clear after this example. See this example now. Now here, see this array A. This array A has 4 elements and we have to sort it in increasing order by insertion sort algorithm, right? So we will start from the second element of this array, right? It means we will start from this element, that is element 2, right? Element which are at the left of it, right, are already sorted, right? There is only one element at the left of it, right? It is 5, right? So obviously it is sorted, right? Now we will insert this element 2 at proper place in the sorted elements which are at the left of it, right? So when we insert this element 2 at a proper place in these sorted elements which are at left of it, right, we will get this array, right? Now element 2 is at first position and element 5 is at second position in array, right? Now see the third element, right? Third element of this array is 4, right? All elements which are at the left of it, right? These elements which are at the left of this element 4, they are already sorted, right? Now we have to insert this element 4 at right place in these sorted elements, right? We have to insert this element 4 at proper place in these sorted elements, right? Now see here, 4 is greater than 2 but less than 5. So it will be inserted between 2 and 5, right? So after inserting 4 in these elements, we will get this array, right? Now see the fourth element, that is the last element of array. It is 1, right? All elements which are at the left of this element in array are already sorted. Now this element 1 will be inserted at proper place in these sorted elements, right? Element 1 is the smallest element among these elements, right? So it will be inserted at first position in array, right? So after inserting this element 1 in these sorted elements, we will get this array, right? Now the array which we have now, its all elements are sorted, its all elements are arranged in increasing order, right? Now this array is sorted in increasing order, right? Now let us see the algorithm of insertion sort for sorting the elements of array A in increasing order, right? Here we have assumed that the lowest index of array A is 1, right? First of all, a for loop is started, right? Initial value of variable j is 2 and this for loop executes until value of j becomes larger than the length of array, right? After each pass in for loop, the value of variable j is increased by 1, right? Now, let us see what happens in each pass of for loop, right? The element which is stored at index j in array is inserted at proper place in the sorted elements which are at the left of this element in array, right? Their indexes in array A are less than j, right? Now, see how element at index j will be inserted at proper place in these sorted elements, right? How element at index j will be inserted at right place in these sorted elements. First, the element which is stored at index j, its value is assigned to a variable key, right? Now, this value key is compared with elements at index 1 lower than j, right? If it is greater than key, then we will shift it to one position right in array, right? That is, we will shift it at one higher index, right? Then we will compare element at next one lower index, right, with key, right? If it is greater than key, then we will shift it to one position right in array, right? We will keep on comparing the elements with key and shifting them one position right, right? And each time we will take element with one lower index than the previous one, right? We will stop when either we reach at index 0 in array A, or we get an element whose value is less than key, right? If we have reached index 0 in array, then it means key is the smallest element among sorted elements. So we will store key at index 1, right? We will store key at index 1, right? Now, if we have got an element whose value is smaller than key, then we will store key at right position to this element, right? That is, we will store key at index 1 more than the index of this element, right? Now we see how it is implemented in this algorithm, right? How this thing is implemented in the algorithm. Value of j minus 1 is assigned to a variable I, and a while loop has been started, right? And in each pass of this loop, value of key, right, value of key is compared with element at index I in array, right? If element at index I in array is greater than key, it is shifted to one position right in array A, right? It is shifted to one position right in array A, right? Initially, the value of I is j minus 1, right? So first of all, the element which is at index j minus 1 is compared with key, right? Then the value of I is decreased in each pass, right? So that next element of array which is at the left of the previous one can be compared with key, right? This while loop executes as long as value of I is greater than 0 and value of element stored at index I is greater than key, right? If either value of I becomes a 0 or value which is stored at index I is lesser than key, then this while loop stops and the value of key is stored at index I plus 1, right? If I becomes 0, then key is stored at index 1 because the key is the smallest element among sorted elements, right? If element at index I is smaller than key, then key is stored at the index 1 higher than the index of this element, right? It will be more clear after this example, right? Now see this array. In this array A, the element which is stored at index 5 is 3, right? Now all the elements which are at the left of this element are sorted, right? Now we have to insert this element which is at index 5 at proper place in these sorted elements, right? Then how will we do this, right? We have to insert this element which is stored at index 5, right? Now here the value of j is 5 because we have to insert the element which is stored at index 5. So here the value of variable j is 5, right? Now the value which is stored at index j, it means the value which is stored at index 5 is assigned to variable key, right? So here the value of key is 3 because the element which is stored at index 5 is 3. So the value of variable key is 3, right? Now the value of variable I, right? The variable I, right? The value of variable I is j minus 1, right? So here the value of variable I will be 5 minus 1, that is 4, right? Now here the value of I is 4. Now we will compare the value of key with the element which is stored at index I, right? Now here the element which is stored at index I means which is stored at index 4 is 7. It is greater than key, right? So what will we do? We will shift the element which is stored at index I to one position right, right? We will shift the element which is stored at index 4 at one position right, right? So at index 5 also this element 7 will be stored, right? Now we will decrease the value of I by 1, right? Now the value of I has become 3, right? Now we will compare the value of element which is stored at index 3 with the key. The value of element which is stored at index 3 is 6, right? And it is greater than key, right? So we will shift this element to one position right in array, right? So now the element which is stored at index 4 will become 6, right? Because we have shifted this element which is stored at index 3 to one position right, right? Now we will decrease the value of variable I by 1, right? Now the value of variable I is 2, right? Now we will compare the value which is stored at index 2 with the key. The value which is stored at index 2 is 4. It is greater than key. So again we will shift the value stored at index 2, right? The value which is stored at index I, that is at index 2, to one position right, right? Now the value which is stored at index 3 is also 4, right? Now we will decrease the value of I by 1, right? Now the value of I has become 1 after decreasing it by 1, right? Now the value stored at index 1 is 2 and it is lesser than key, right? So we will store this key at index I plus 1. It means we will store this key at index 2, right? So after inserting this key at index 2, we will get this array, right? Now see, this element 3 has been placed at proper place in these sorted elements, right? Now see one more example. Now see here, suppose we have to insert this element which is stored at index 5 in this array A at proper place in the sorted elements which are at the left of this element, right? Now this element is stored at index 5, right? So here the value of variable j is 5, right? Now the value which is stored at index j means which is stored at index 5 is 1. So the value of variable key is 1, right? Now the value of variable I is j minus 1. So the value of variable I is 4, right? Now we will compare the key with the value which is stored at index I. The value which is stored at index I is 7 and it is greater than key. So we will shift this value at one position right, right? Now the value which is stored at index 5 has become 7, right? Now we will decrease the value of I by 1. So the value of I has become 3. Now we will compare the value which is stored at index 3 with the key. Value which is stored at index 3 is 6. It is greater than key. So again we will shift it to one position right, right? Now the value which is stored at index 4 has become 6. Now we will decrease the value of I by 1, right? Now the value of variable I has become 2, right? Now the value which is stored at index 2 is 4. It is greater than key. So we will shift this value at one position right in array, right? Now the value stored at index 3 has become 4. Now we will decrease the value of I by 1. Now the value of I has become 1. Now the element which is stored at index 1 is greater than key. So we will shift it to one position right, right? And we will decrease the value of variable I by 1. Now the value of variable I has become 0, right? So we will stop there, right? And the value of key will be stored at index I plus 1, right? It means the value of key will be stored at index 0 plus 1, that is at index 1, right? Here the value of key is stored at index 1, right? Now after inserting the value of key at index 1, we will get this array, right? Now see, these elements are arranged in increasing order, right? In this way we have inserted the value of key at proper place in the sorted elements.